Earth drifts through space with the quiet confidence of a survivor, wrapped in an atmosphere that feels permanent and skies that seem eternal. From the surface, the universe appears calm, distant, and mostly harmless, a backdrop of stars that inspire wonder rather than fear. Yet beyond that thin blue veil lies an environment so violent and unpredictable that extinction can arrive without warning, without countdown, and without mercy. The most dangerous threats to Earth are not always the ones we watch closely. Many of them are hidden, fast, invisible, or misunderstood, capable of ending civilization before humanity even realizes what is happening. One of the most terrifying dangers comes not from massive, easily detectable asteroids, but from smaller space rocks that move at extreme speeds and arrive from unexpected directions. These objects do not announce themselves with decades of notice. Some approach from the direction of the sun, blinding our telescopes and rendering detection nearly impossible. A city-killer asteroid only a few hundred meters wide could enter Earth's atmosphere with less than a day of warning. Traveling faster than a rifle bullet multiplied thousands of times, it would release energy equal to thousands of nuclear weapons upon impact. Entire metropolitan regions could vanish in seconds, triggering global shockwaves, fires, and atmospheric debris that disrupt climate systems worldwide. Even more deceptive are cosmic fragments that never reach the ground. When space rocks explode in the atmosphere, as happened over Tunguska in 1908, they can flatten millions of trees without leaving a crater. A similar event over a modern city would result in casualties beyond comprehension. Glass would shatter across hundreds of kilometers, infrastructure would collapse, and emergency systems would fail instantly. Because these events leave little physical evidence, they remind us how easily history can forget near misses, creating a dangerous illusion of safety. Beyond rocks and debris lies a threat that cannot be seen at all until it is too late. Gamma-ray bursts are among the most powerful explosions in the universe, released when massive stars collapse or neutron stars collide. If a gamma-ray burst were aimed directly at Earth from within our galaxy, it could strip away large portions of the ozone layer in seconds. The sky would not explode, and the ground would not shake, but the damage would unfold silently. Without ozone, lethal ultraviolet radiation from the sun would pour onto the surface, sterilizing oceans, collapsing food chains, and triggering mass extinction. Humanity might survive briefly in shelters, but the biosphere that sustains life would unravel over years rather than moments. Even more unsettling is the possibility that such a burst could arrive with no warning at all. Gamma rays travel at the speed of light. By the time we detected them, the damage would already be done. There would be no evacuation, no defense, no heroic intervention. The planet would simply begin to die under a sky that looks perfectly normal. Another hidden danger flows constantly through Earth, unnoticed and unstoppable. Cosmic radiation from deep space bombards the planet every second, mostly deflected by Earth's magnetic field. But that magnetic shield is not stable. Geological records show that Earth's magnetic poles flip periodically, weakening the field for centuries during the transition. If a major solar storm were to strike during such a weakened phase, charged particles could penetrate deep into the atmosphere. Satellites would fail instantly, power grids would overload and burn out, and global communication would collapse. In a world dependent on electronics for food distribution, water systems, medical care, and transportation, such a failure could cascade into global chaos within days. The sun itself, the very source of life, hides destructive potential. Massive solar flares and coronal mass ejections erupt. Without predictable schedules, a sufficiently powerful solar storm could induce electric currents strong enough to destroy transformers across continents. Unlike most disasters, damaged transformers cannot be quickly replaced. Manufacturing them takes months or years. A prolonged global blackout would not be a temporary inconvenience. It would be a civilization-ending event marked by famine, social collapse, and widespread loss of life long before power was restored. Lurking even closer is a threat humanity rarely considers. Space debris, the junk left behind by decades of exploration, orbits Earth at incredible speeds. A single collision between satellites can create a chain reaction known as the Kessler syndrome, filling orbital space with shrapnel. If this cascade becomes uncontrollable, access to space could be lost for generations. Weather monitoring, GPS navigation, communication networks, and early warning systems for incoming threats would all be crippled. Earth would not be destroyed outright, but humanity would be blinded and isolated at the very moment vigilance is most needed. Some dangers do not arrive from afar, but awaken from within the galaxy itself. Rogue stars and black holes drift silently through space. A close pass by a massive object could disturb the Oort cloud, a distant shell of icy bodies surrounding our solar system. Such a disturbance could send a rain of comets toward the inner planets, lasting millions of years. The first impacts might seem random, but over time the probability of catastrophic collisions would rise dramatically. Civilization could be erased not by one event, but by a slow, relentless bombardment that never truly ends. Perhaps the most chilling threats are the ones we do not yet understand. The universe is vast, and humanity's knowledge is still young. Unknown cosmic phenomena may exist that have not yet touched Earth, not because they are impossible, but because the timing has simply not aligned. Throughout Earth's history, mass extinctions have occurred without warning, rewriting life's story in moments. The universe does not announce its intentions, and it does not negotiate. Earth survives not because it is protected, but because it has been lucky. That luck has lasted long enough for intelligence to emerge and ask questions about its own fragility. Whether that intelligence lasts depends on recognizing that danger does not always arrive with fire in the sky. Sometimes it comes as light, radiation, gravity, or silence. Sometimes it arrives faster than thought, faster than fear, and faster than any warning humanity could hope to receive. The silence of space is deceptive because many of its deadliest forces do not roar, burn, or announce themselves in any dramatic way. Some drift patiently, waiting for alignment, while others strike so suddenly that cause and effect feel indistinguishable. One such invisible killer lies in the fabric of space itself. High-energy neutrinos pass through Earth constantly, usually harmless, rarely interacting with matter. Yet there exists a theoretical possibility that a concentrated neutrino burst from a nearby cosmic event could disrupt atomic structures on a massive scale. While still speculative, it highlights a sobering truth that even particles once thought irrelevant can become catastrophic under the right cosmic circumstances. The universe does not operate on human assumptions of scale or relevance. Dark matter, which makes up most of the mass in the universe, remains one of the greatest mysteries. It does not emit light, cannot be touched, and passes through ordinary matter as if it were not there. Some theories suggest Earth may periodically pass through denser regions of dark matter as the solar system orbits the galaxy. If dark matter interacts with normal matter even slightly more than we expect, it could influence Earth's core temperature, increase volcanic activity, or subtly alter radioactive decay rates. A slow destabilization of Earth's interior could trigger super-volcanic eruptions without the usual geological warnings, darkening the sky with ash and plunging the planet into a volcanic winter that lasts for decades. Supervolcanoes themselves are another threat tied indirectly to cosmic forces. Gravitational interactions with the moon, the sun, and even passing celestial bodies can influence tectonic stress. A sudden shift in stress distribution could awaken dormant magma chambers like Yellowstone. A full-scale eruption would not simply affect a region or a continent. It would inject so much sulfur and ash into the atmosphere that global temperatures would plummet, crops would fail worldwide, and sunlight would dim into a permanent twilight. Unlike asteroid impacts, this would not be a sudden end, but a drawn-out collapse where starvation becomes the primary executioner. Then there is the threat of interstellar dust clouds. As the solar system moves through the galaxy, It occasionally passes through regions of higher dust density. A dense enough cloud could compress the heliosphere, the bubble that shields us from cosmic radiation. With that protection weakened, Earth would be exposed to increased radiation levels for thousands of years. DNA damage would rise, cancer rates would skyrocket, and ecosystems would suffer genetic collapse. Evolution might continue, but humanity's place in it would be far from guaranteed. Another overlooked danger comes from fast radio bursts, mysterious pulses of radio energy originating from distant galaxies. Most pass harmlessly through space, but their sheer intensity suggests unimaginable power at the source. If one were to originate close enough, it could induce currents in electronic systems worldwide. Unlike solar storms, this would not come from our own star and might strike without any correlation to solar activity. Global electronics could fail in an instant, not gradually, leaving humanity stunned by a technological blackout. With no clear explanation, even Earth's orbit is not as stable as it appears. Gravitational nudges from planets, asteroids, and passing stars can subtly alter orbital parameters over time. A small change in Earth's distance from the Sun could have catastrophic consequences. A slight inward shift would intensify heat, melt ice caps completely, and accelerate runaway greenhouse effects. A slight outward shift could trigger a deep freeze, expanding ice sheets until much of the planet becomes uninhabitable. These are not dramatic collisions, but slow drifts that lock Earth into irreversible climate states. The Moon, often seen as a silent companion, also carries hidden risk. Its stabilizing effect on Earth's axial tilt has allowed climate stability for millions of years. If a large asteroid were to strike the Moon, altering its orbit even slightly, Earth's tilt could begin to wobble chaotically. Seasons would become extreme, weather patterns unpredictable, and long-term agriculture nearly impossible. Civilization depends on predictable cycles, and without them, complex societies cannot endure. Perhaps the most unsettling danger is the possibility of a nearby star going supernova. While rare, stars massive enough to explode exist within distances that could affect Earth. A supernova within a few dozen light years would flood the planet with radiation, damage the ozone layer, and potentially trigger mass extinction. Geological evidence suggests this may have happened before, leaving traces of radioactive isotopes embedded in ocean sediments. These cosmic fingerprints hint that Earth has already endured such encounters, surviving by chance rather than preparedness. Space also holds threats that exploit human progress itself. As technology advances, humanity becomes more dependent on space-based infrastructure. Navigation, finance, defense, weather prediction, and even agriculture rely on satellites. A sudden cosmic event that wipes out orbital assets would not just be a technological setback, but a systemic failure. Society would fracture along lines of access and adaptation, and recovery would be uncertain in a world already strained by population and resource limits. What makes these dangers truly frightening is not just their power, but their unpredictability. Many operate on timescales beyond human memory and perception. They do not conform to schedules, elections, or economic cycles. They do not care whether humanity is ready. Earth's history is filled with sudden endings followed by long recoveries. The difference now is that one species is aware of the risk, yet remains largely powerless against many of these cosmic forces. There is a quiet arrogance in the way humanity measures danger, as if threats must fit familiar shapes to be taken seriously. We imagine destruction as something visible, something that burns, crashes, or explodes in the sky. Yet some of the most lethal possibilities are subtle, unfolding in ways that mimic normality until the damage is irreversible. Space is not just a place of impact events, but a domain of slow killers that erode stability molecule by molecule, year by year, until collapse feels sudden only because the warning signs were misunderstood. One such danger lies in cosmic time itself. The solar system does not travel through a static environment. It oscillates above and below the plane of the Milky Way, passing through regions of varying gravitational density and radiation exposure. Some hypotheses suggest that these oscillations may correlate with periodic mass extinctions in Earth's history. As the solar system moves through denser galactic regions, gravitational disturbances may increase comet influx, while radiation exposure subtly damages life at the genetic level. The extinction does not arrive as a single blow, but as an accumulation of pressures that overwhelm ecosystems already pushed to their limits. There is also the haunting possibility of vacuum decay, a theoretical phenomenon, rooted in quantum physics. According to some models, the universe may exist in a metastable state, meaning it is not in its lowest possible energy configuration. If a region of true vacuum were to form somewhere in the universe, it would expand at the speed of light, rewriting the laws of physics as it goes. Atoms would not survive, forces would behave differently, and life, as we know it, would cease instantly. There would be no warning, no flash, no pain. One moment the universe would exist, the next it would not, at least not in any recognizable form. While the probability is unknown, the mere existence of such a possibility reminds us how fragile reality itself may be. Another unsettling risk comes from artificial objects drifting through interstellar space. Humanity is not the only civilization that could have existed in the galaxy's long history. If technological civilizations arise and fall, they may leave behind autonomous machines or probes that continue to operate long after their creators are gone. An encounter with an ancient, self-directed system could pose unpredictable dangers, especially if its purpose or logic no longer aligns with any living intelligence. Even without hostile intent, advanced technology can be dangerous simply by existing in the wrong context. Closer to home, the accumulation of near-Earth objects continues silently. Not all threats come from single large bodies. Swarms of smaller objects, fragmented by earlier collisions, can arrive in clusters. Individually, each impact may seem manageable, but collectively they can overwhelm global response systems. Multiple impacts within days or weeks would strain emergency resources, ignite widespread fires, and inject enough debris into the atmosphere to alter climate patterns. Civilization is resilient to isolated disasters, but it is vulnerable to sequences that allow no recovery time. The deep oceans, which cover most of Earth's surface, offer another vulnerability tied to cosmic influence. A large enough impact in the ocean would displace unimaginable volumes of water, generating mega tsunamis that race across entire ocean basins. Coastal cities would be erased, ports destroyed, and global trade shattered. Salt water would infiltrate freshwater systems, farmland would be poisoned, and food production would collapse. The ocean, often seen as a buffer against impacts, could instead become the medium through which destruction spreads. Even the sky itself can become hostile. If Earth were exposed to a sustained increase in cosmic radiation, clouds could be altered at the molecular level. Changes in cloud formation would disrupt rainfall patterns, intensifying droughts in some regions and flooding others. Agriculture, finely tuned to stable climate rhythms, would struggle to adapt. Hunger would not arrive with an explosion, but with empty fields and failing harvests. What makes these threats uniquely terrifying is that many do not distinguish between species, nations, or ideologies. They do not target borders or infrastructures selectively. They act on planetary scales, rendering political power and military strength irrelevant. Humanity's greatest weapons would be useless against a shifting orbit, a radiation storm, or a fundamental change in physical laws. Awareness does not equal control. While scientists monitor the skies and model probabilities, the universe retains the advantage of scale and time. Events that seem unlikely on human timescales become inevitable given millions or billions of years. Earth has been spared recently, but recent does not mean safe. It only means the dice have not yet landed on catastrophe. Perhaps the most unsettling realization is that extinction does not require malice, intent, or even violence. It requires alignment. A star at the wrong distance, a particle with the wrong energy, a rock arriving from the wrong direction, or a subtle shift occurring at the wrong moment. Life on Earth exists in a narrow window of conditions, balanced on variables that can be altered by forces far beyond the planet itself. There is a profound discomfort in acknowledging that Earth's survival is not guaranteed by strength or intelligence, but by circumstance. The planet moves through a cosmic environment that does not notice life and does not adjust its behavior to protect it. In this environment, even stability can be a temporary illusion, maintained only until a distant interaction ripples inward and reaches us. Some of the most dangerous threats are not dramatic in their arrival, but devastating in their consequences precisely because they appear ordinary at first. One such threat is the gradual brightening of the sun. Over long periods, stars like our own increase in luminosity. While this process unfolds over hundreds of millions of years, smaller fluctuations can accelerate warming in ways that push Earth past critical thresholds. Increased solar output combined with cosmic influences could trigger runaway feedback loops. Ice reflects sunlight, but as it melts, darker surfaces absorb heat, accelerating warming. Oceans release dissolved gases, weakening atmospheric regulation. At a certain point, even if the original trigger fades, the process cannot be reversed. Earth would slowly transform into a world hostile to complex life, not through explosion, but through an irreversible slide. The stability of Earth's atmosphere is another fragile balance influenced by space. Atmospheric escape is a continuous process, with light gases gradually drifting into space. Normally, Earth's gravity and magnetic field keep this loss in check. But if those protective factors were weakened by cosmic events, atmospheric loss could accelerate. Mars serves as a warning, a planet that once had rivers and lakes, now stripped and frozen. Earth could follow a similar path over geological time, its skies thinning until liquid water becomes impossible at the surface. There are also threats tied to resonance, a concept where small forces accumulate power through repetition. Gravitational resonances with other bodies in the solar system can amplify orbital and rotational variations. Over time, these resonances can destabilize planetary systems. While such changes usually occur over immense timescales, sudden shifts are not impossible if multiple influences align. A minor change in Earth's rotation rate could alter wind patterns, ocean currents, and weather systems globally, disrupting climates that have remained stable long enough for civilization to emerge. The idea of interstellar clouds brings with it another chilling possibility. Dense regions of molecular gas can contain not only dust but also reactive compounds. Passing through such a region could seed Earth's upper atmosphere with unfamiliar chemistry. Ozone depletion, altered cloud nucleation, and changes in atmospheric transparency could follow. Life evolved under a specific spectral balance of sunlight, and altering that balance could stress ecosystems in ways that evolution cannot quickly adapt to. Then there is the reality of cumulative exposure. Earth is constantly bombarded by micrometeorites, cosmic rays, and solar particles. Individually, these are negligible. Collectively, over long periods, they shape planetary evolution. A sudden increase in this background exposure could act as a global mutagen, increasing mutation rates across all species simultaneously. While mutation drives evolution, excessive mutation destabilizes it. Ecosystems rely on genetic continuity. When that continuity is broken too rapidly, collapse follows. Human perception struggles with slow disasters. A threat that unfolds over centuries feels abstract, distant, and hypothetical. Yet these are often the most dangerous because they bypass instinctive responses. Humanity prepares for storms, earthquakes, and wars, but not for gradual shifts that erode resilience. Space-driven threats often operate in this slow domain, altering baselines rather than delivering shocks. By the time collapse becomes visible, options for response may already be gone. There is also the possibility of compounded disasters. A solar storm does not need to end civilization on its own. It only needs to strike when society is already weakened by other stresses. A weakened magnetic field combined with high solar activity, political instability, and environmental strain could push global systems past recovery thresholds. Space does not need to destroy Earth directly. It can simply remove the margins that allow civilization to survive adversity. Earth's history shows that life persists, but it does not promise continuity. Most species that have ever existed are extinct. Intelligence offers no immunity from cosmic indifference. In fact, intelligence may increase vulnerability by binding survival to fragile systems. The more complex civilization becomes, the more points of failure it creates. The greatest danger may be complacency. The night sky looks peaceful, unchanged from one generation to the next. Stars rise and set, seasons return, and disasters seem local and manageable. This familiarity breeds the assumption that tomorrow will resemble today. But the universe does not operate on human rhythms. It waits, it drifts, and then it changes everything. Humanity often speaks of the end of the world as a single moment, a final scene marked by fire, darkness, or silence. In reality, cosmic destruction is more often a process than an instant, a chain of causes that unfold with brutal inevitability once initiated. Space does not rush. It applies pressure patiently, exploiting weaknesses until collapse becomes unavoidable. The tragedy is not only that Earth could be destroyed without warning, but that warning may come in forms we are not prepared to recognize. One of the least understood dangers is the interaction between cosmic forces and Earth's biosphere at the microbial level. Life on this planet depends on microscopic organisms that regulate oxygen, nitrogen, and carbon cycles. Increased radiation from space, even if not immediately lethal to humans, could decimate these invisible foundations. Phytoplankton in the oceans produce a significant portion of the oxygen humans breathe. A radiation-driven collapse of plankton populations would not make headlines at first. The sea would still look blue, the air would still feel normal, but oxygen levels would slowly decline while carbon dioxide rises. By the time the effect is noticeable, reversing it could be impossible. Another silent threat comes from the possibility of Earth encountering exotic forms of matter. Hypothetical objects such as strangelets, tiny fragments of strange matter, could theoretically convert ordinary matter into more strange matter upon contact. If such an object were to strike Earth and remain stable, it could begin transforming the planet from the inside, altering atomic structures at the core. While highly speculative, this scenario highlights how little we truly know about the range of matter that may exist in the universe, and how catastrophic even a microscopic intruder could become under the wrong conditions. Space also carries the risk of informational catastrophe. Humanity relies on data to understand and respond to threats. A sudden cosmic event that disrupts satellites and ground-based observatories could blind scientific monitoring systems. Without the ability to observe the sun, track near-Earth objects, or measure radiation levels, decision-making would revert to guesswork. Panic and misinformation would spread faster than facts. In such an environment, human behavior itself could accelerate collapse more effectively than the original cosmic trigger. There is a psychological dimension to cosmic danger that is rarely discussed. The realization that destruction can arrive without cause or blame challenges fundamental beliefs about control and meaning. Societies under existential stress often fracture, turning inward rather than outward. Cooperation becomes difficult when the threat has no face and no solution. Space-induced disasters do not provide an enemy to fight, only conditions to endure. History suggests that endurance alone is rarely enough to preserve complex civilizations. Even time itself can become a weapon. Relativistic objects moving at extreme velocities carry immense kinetic energy. A fragment no larger than a grain of sand, traveling at a significant fraction of light speed, would release energy comparable to an explosion upon impact. Such objects would be nearly impossible to detect before collision. While rare, The vastness of space makes rarity a weak form of reassurance. Given enough time, even improbable events occur. Earth's position within the solar system has so far been remarkably fortunate. Giant planets like Jupiter act as gravitational shields, deflecting many incoming objects. But this protection is not absolute. Gravitational interactions can also redirect threats inward. A slight change in Jupiter's orbit, caused by distant stellar encounters over millions of years, could alter the balance that currently protects Earth. What shields us today could expose us tomorrow. There's also the possibility of cascading ecological collapse triggered by a single cosmic disturbance. A modest cooling or warming event, initiated by atmospheric changes from space radiation or dust, could push vulnerable ecosystems past tipping points. Coral reefs bleach and die, forests burn or fail to regenerate, polar ice collapses into the ocean. Each loss amplifies the next. The planet does not need to be shattered to become uninhabitable for humans. It only needs to lose the systems that quietly support life. Perhaps the most sobering aspect of these dangers is that many leave no clear evidence behind. Future civilizations, if any arise, may look back at the end of our era and see only a gap, a sudden change in sediment layers, a shift in isotopic ratios. They may never know whether humanity fell to a rock, a ray, a storm of particles, or a slow unraveling driven by forces no one could see. Earth has endured cosmic violence before. Asteroids have struck, radiation has surged, climates have flipped. Life persisted because it was simple, adaptable, and abundant. Civilization is none of these things. It is complex, specialized, and dependent on stability. Space does not need to destroy the planet to end the human story. It only needs to disturb the balance long enough for complexity to fail. In the end, the most unsettling truth about hidden dangers from space is not their power, but their indifference. The universe does not aim at Earth, yet it does not avoid it either. Planets are not protected by destiny, and life is not guaranteed continuation simply because it exists. Earth moves through a cosmic landscape shaped by forces that are ancient, vast, and unconcerned with survival. Every orbit, every rotation, every passing moment is a negotiation with conditions that can change without notice. Humanity's awareness of these threats is a relatively new development, a brief flicker of understanding in a planetary history measured in billions of years. For most of Earth's existence, life had no warning system, no telescopes, no equations to describe what was coming. Extinctions arrived, reshaped the biosphere, and moved on. The fact that humans can now imagine cosmic dangers does not mean they can prevent them. Knowledge reveals vulnerability as much as it offers hope. What makes space-based threats uniquely terrifying is that they bypass the narratives humanity relies on. There is no villain to defeat, no negotiation to attempt, no moral framework that can influence outcome. A gamma ray burst does not care about culture or achievement. A gravitational shift does not pause for adaptation. These forces act according to physics alone, and physics does not compromise. Earth's continued habitability depends on a chain of unlikely conditions remaining intact. The magnetic field must hold. The atmosphere must remain thick enough. The orbit must stay within narrow limits. The sun must remain stable enough, and the galaxy must not deliver a surprise too close for comfort. Any break in this chain, even a small one, can propagate into catastrophe. Survival is not a single safeguard, but a fragile alignment. There is also the uncomfortable realization that prevention has limits. Some threats can be monitored, deflected, or mitigated. Others cannot. No technology can shield an entire planet from a nearby supernova or rewrite the structure of space-time. At best, humanity can increase resilience, diversify habitats, and extend awareness. Even then, success is not guaranteed. Space operates on scales that dwarf intention. Yet within this vulnerability lies a rare responsibility. Humanity may be the first species on Earth capable of recognizing that extinction does not require failure, only exposure. This awareness carries an ethical weight. It challenges complacency and demands humility. It suggests that survival is not an entitlement, but an ongoing condition that must be respected and protected where possible. The night sky remains beautiful because danger does not advertise itself. Stars do not flicker with warning labels, and darkness does not reveal what is moving through it. From the ground, the universe feels distant and serene. From a cosmic perspective, Earth is a small target in a shooting gallery of chance events, spared so far by timing rather than immunity. If the end ever comes from space, it may not be remembered as an invasion or a war, but as a sudden silence, a gradual dimming, or a shift so subtle that those living through it do not realize what has been lost until survival itself becomes impossible. The story of Earth would not end in anger or judgment, but in physics doing what it has always done. Until then, Earth continues its quiet journey, suspended between forces that sustain it and forces that could erase it without warning. The true danger is not that such events are certain, but that they are possible, and that possibility exists every moment the planet continues to turn beneath an indifferent sky.